Computer screen share. All right. Everybody online can hear me and see my screen and all that jazz. So let's talk about the midterm. And then we'll talk about some other stuff today. So midterm exam, we're going to have this a week from this past Wednesday. So what will that be? The 15th? Says Wednesday, 3:15 during the scheduled class time on Blackboard. So just like our last several exams you've had with me, doing on Blackboard, it's easier to grade. It'll be during class time. You don't have to come in person to class or anything. I will be at a computer available during the exam. So if you have real-time questions or something like that, throw a question on Slack and to me, and I'll answer it right away. The exam will be designed to take about 30 minutes with the idea that there should not be a time crunch issue. I know some students do get some extra time on exams and things like that. Reach out to me and we'll make sure that we go and put on your exam an extension and things like that. And then we can also set it up so you can take it at a different time. So we'll be accommodating to all those things. Go ahead.
So is that Monday the 15th or Wednesday the 17th?
When it's Wednesday the 17th? What's today? Today's the 12th, right? Oh, Wednesday the 17th. Thank you. Because 12 plus 7 is 19, isn't it? Oh my gosh, I'm glad it's Friday. All right, Wednesday the 17th. Thank you. So not next class. Next class, what we'll do is I'll start off by taking any questions if you want me to review anything, and we're going to go through the slides a little bit today, and I'll kind of point out highlights, things that I think might make the exam, things that you should definitely know, that kind of stuff. So then your kind of, let's say your homework for Monday will be to do some studying for this exam. And if you have things you want me to clarify on Monday before we get into some things that won't be on the exam, but we'll start the next topics, let me know and I can cover those things on Monday. Okay. So my exams are designed to fit comfortably inside the class period. Okay. All my exams have 10 questions. There will be at least one conversion question. So that is either going to be, converting from one base to another base, or possibly from a size to another size. You know, how many kilobytes is, 3 gigabits, something like that. So making sure you understand that chart of, a byte is 8 bits and it's 1024 multipliers as you go down the list. These are things that computer scientists should know regardless of what class you're in. And hopefully that stuff is even more relevant to you this semester with the 325 class. Hopefully you've been working quite a bit in binary, octal, and hexadecimal, or at least seeing a lot of examples of those things. All right, so I will always ask at least one conversion question on any exam you ever have with me, through even grad school. it's gonna be on there and should be free points. Unfortunately, sometimes it ends up not being that. All right, the exam will be roughly half programming and half theory. And I'll go through and give you an idea of kind of the type of programming questions I'm going to ask. Most of them are going to be more along the lines of string manipulation, things like that, kind of like little exercises, kind of showing me your ability to program at this point. Because really what I'm assessing is how are you coming along in terms of computer programming competence since CSC200. And when you get into 300 next semester, I'll be assessing the same type of thing. You should be a stronger programmer, be able to handle a little bit more complex things and that kind of stuff. All right. And like I said, the exam will be on Blackboard. I'll open it probably a couple minutes before class starts. It'll close a couple minutes after class. Reach out to me if you have accommodations for extra time and things like that, and we'll set your exam up to be right. I don't think anybody will have an issue with time though. And if you do, it's probably because you weren't prepared for the exam. And as usual, I have my policy where if you do better on the final exam than you did on the midterm, I'll replace your midterm exam score with what you get on the final exam. So hopefully this ends up being somewhat of like a wake-up call type thing. All right, so let's bounce back towards the beginning of the class. And let's kind of go through the slides one by one, and I'll point out areas of interest versus things that, hey, you should obviously know, but I'm probably not going to test you on it, that type of thing. All right, so like this slide, these are things you should know. I'm not going to ask you to tick off the way human beings solve problems type of thing. That was a 200 concept. Same thing when we deal with the different types of languages. This is something from CSC250, and really we spent some time at the beginning of the semester doing that mapping to kind of understand where Java fit in the world. So I won't ask you specific questions with this. It would be fair game to ask something along the lines of how does Java actually work, where Java gets compiled, turned into Java bytecode, ultimately runs on a Java virtual machine. I would call it a relatively low chance I'll ask a specific question about that, but you certainly should be able to describe how the language you're currently working with works. If you remember back when we were talking about this, we actually compiled Java out at the command line, went and saw that .class file that gets created and looked at how it ran, because then we converted over to Eclipse where we just hit a pretty play button and it just works. All right. I won't ask questions like how do you compile a Java program or whatever, but the very least you should know that Java is a compiled language. Ultimately, what's a compiler? It converts high-level code into a low-level language. The low-level language the Java compiler converts it to is called Java bytecode. And ultimately, the machine that Java bytecode runs on is called the Java virtual machine. So it's a computer built-in software. All right. Certainly understand that concept of loosely typed versus strongly typed. That's something that we've had to modify our thinking. When we worked with Python last semester, we were working with a loosely typed language. When we created variables, we didn't have to specify the kind of value that variable was built to hold. Now we're working with a strongly typed language where we are responsible for the kinds of values that variable is meant to hold. So defining a variable requires us to attach a type to it, and that comes with, let's say, consequences. So typically strongly typed languages are faster languages. They also tend to be compiled languages. So all those concepts would be all fair game for the exam. This slide as well, kind of this idea of that compiler's targeting two things. It wants to know what your architecture is, what CPU is this built to run on, and then what's the operating system. The concept of a virtual machine would be fair game, but I'm probably not going to waste a lot of questions on stuff like this. The idea is that the Java virtual machine is a computer written in software, and actually the Java bytecode runs on that guy. And that guy kind of does the one-to-one interpreter action to make it run on the native CPU of the computer you're executing the code on. Be able to write a error-free hello world program in Java. Almost guaranteed that'll be on the exam. All right, and I'm not a big advocate in general of memorization, but I think memorizing things like this is important because, one of the things that I focus on is this idea that the programming is the skill set, the language doesn't matter. That's why we keep bouncing between technologies. In fact, now we're going to start looking at Android development the second 8 weeks of and I might even start that today, depending on how far we get here. Otherwise, we'll start it on on Monday, but and that won't be on the exam, the Android stuff that we start with, but that's how we'll be spending same content we're going to keep working with. We'll just be exploring it in the context of Java, but within the Android development environment. So anyways, understanding kind of the basic template for writing a starter program in these different languages, I think is a really important skill and something you really probably should have memorized, because if you are sitting somewhere and you need to write a Java program, for example, if you can hammer out a quick hello world program in that and get it working, and you know your development environment's all functional, from there you can then focus on solving the problem at hand and not trying to get your development environment set up. All right. So pretty much promise you, you'll have to write this exact words on the exam for 10% of the exam. So missing anything on that will be problematic, because I just warned you it will be on there. Okay. All right. I probably won't ask any question dealing with file IO on the exam. I think we just looked at the code here real quick. This is stuff, if you need to read from a file, you pop in the code, get it reading from the file, then you start working with the stuff. I'm not going to waste time on an exam having you read stuff in from weird locations. The programming questions on the exam, though, will most likely take in either strings, arrays, or array lists, and have you do something with those things. That's the kinds of questions I like asking. Things I'll be paying special attention to in 250 that were evident in 200, and these are things that you should be past at this point in terms of understanding, is that when you write a function and it takes in some parameters, you're operating on those parameters generically. I should not see your first line of your function overwriting your parameter with some hard-coded value. The idea is that functions get called by somewhere else in your program, and inputs to those functions get passed along at that point. You don't write a generic function and then line one, have the thing take in an int n, and then on line one say n equals 17. That's hard coding the inputs that this thing's supposed to generically function on. That should be something you should understand by this point in the second programming class. All right, so point deductions would be harsher in 250 for mistakes like that than they were in 200. Because one of the things I try to really measure is the idea of competence, and that's showing not a very high level of competence when it comes to where you should be now. So certainly be able to work with array lists. I won't ask anything about comparing algorithms. We didn't talk about it in super depth anyways, but when we were introducing the searching and sorting type stuff, we kind of said, we might have a way of measuring these guys against each other for performance, whether it's memory efficiency or speed efficiency, whatever it is. And I kind of even mentioned that this whole idea of big O notation, having just some sort of measurement of speed, let's say, kind of comes down to, if we were to really make it generic, how many questions do we need to ask to accomplish something? Recently, we've looked at like insertion sort and selection sort, which have a lot of similarities to each other. And the differences there would have been like, how many questions did we have to ask? Should this guy get swapped with this guy? That's a question. The number of times we have to ask that question adds up to the speed of the algorithm, right? So this is something that I'm not going to say is unimportant. Certainly, being able to, let's say, scientifically measure the speed of different algorithms and stuff like that is an important generic theoretical concept, but it's not something that's in heavy practice today because our computers have gotten very, very fast. So a really, really, really efficient or really, really, really inefficient correct solution is still going to run almost instantaneously for almost every solution. Okay. So not that it's not important, but it's not the type of thing I'm really trying to assess, because what I want you to do is come out of this class with a better computer programming skill set than you did coming into this class. And your ability to memorize the efficiency of different searching algorithms doesn't tell me much about that. All right. I would say don't waste time memorizing the algorithms. Linear search is, pretty, it doesn't assume that your data is sorted at all. You just say start at bucket 0. I'm just going to look for my thing. But I'm not going to test you about, tell me the first 3 steps of insertion sort on this, on this collection of data. Not that it's unimportant, but a quick Google search, you can say, hey, how does insertion sort work again? Somewhere is going to give you the 4 steps, do this, then this, then this, then this. A computer programmer should be able to then take that and implement it. If you think about our last several assignments, they've kind of been those types of things. I'm not looking for you to memorize an algorithm. I want you to be able to write code to implement an algorithm. So don't waste time going back and reviewing how insertion sort exactly works or something like that, because they won't ask you questions about it. The concept of polymorphism could be on there. That would be one of those theory questions where, I want you to understand that it is possible and even sometimes probable for there to be multiple functions in a class with the same name, but that take a different number and or type of parameters, and Java will automatically call the correct function based on what you provided it when you called it. If you have a version of a function that takes in a string and then another version that takes in 2 integers, well, when you're calling it, if you pass it 2 integers, Java will call the version of that in the class that takes in 2 integers. I think we explored this a little bit when we were looking at we had 2 different constructors for our card class, right? We had a constructor for our card class that took in 4 integers, or took in a string and 3 integers, I think, for the cost and the attack and the defense. And then we had another one that took in kind of a string that had all that information in it that we had to kind of piece apart using the JSON parser and that kind of stuff. So both of those guys are constructors. Both of their jobs are to construct a new instance of this object. The information we had to provide them was different. The first constructor, which had the same name as the second constructor, took in a string and 3 integers. So I gave it the 4 pieces of information it needed. We then used it to set those fields and moved on with life. The other one took in a string, presumably a JSON string, and we used that suite. We pulled the information out of that string that we needed to set those same fields in the class. All right, so that would be an example of polymorphism, where we have more than one method, or in that case, a constructor that has the same name and even the same ultimate goal in that case, but we provided it different information, different number and or type of parameter in order for it to accomplish its goal.
I have a question, Dr. Lim.
Sure.
So what if you have 2 methods that have the same name and the same number and type of parameters? Which one would Java use? How would
Java wouldn't do anything. It won't compile.
Okay, so that would be an error.
It's an error. And
Okay.
Java does not care about the variable names. So you can't have a function called do something that takes an int A, and then another one called do something that takes in an int B. Java views those 2 functions as completely identical to each other, even though you listed one of the parameters as being called A and the other one it was called B. Java doesn't care what you name your variables.
Okay.
So, but to your point, the question you were asking is, what if you did have 2 different methods that had the same type of parameters? Java would not be happy about that and won't compile. All right. Certainly understand the difference between an array and array list, why we are choosing to use array lists here. Arrays have a fixed size when we create them, where an array list allows us to arbitrarily add stuff to it. What's happening under the hood with an array list isn't really our problem. Okay, array lists are probably implemented as using contiguous memory, so they are probably fairly memory inefficient under the hood. But we don't care, because we're just creating an array list and we'll add stuff to it willy-nilly, like no big deal. Okay, and if it's being horrible with memory under the hood, we're none the wiser. When you get to the 300 class, we look at this in more depth, and we actually create the kind of the next step up called the linked list, which is memory efficient because we allow it to hold an arbitrary collection of data where we can start off with nothing and then add 4 things to it, subtract 2 things, it doesn't matter. You're always holding it in the correct footprint of memory. But that comes at the cost of not having contiguous memory. When I say contiguous memory, what am I talking about? This would be another theory question that could show up on the exam. What do I mean by a contiguous memory? It deals with arrays. When we talk about, when we first talked about arrays in here, and even when we talked about lists in 200, contiguous memory is memory next to each other, memory in a row. That's why arrays are fast. All right, so arrays, when they're implemented, you say, I need 10 elements. I need to hold 10 integers, let's say. All 10 of those buckets are right next to each other in memory. And that equals fast, but it also has the constraint of saying, look, you asked the operating system for enough memory to hold 10 integers. Now you're telling me you want to hold 11? I can't just necessarily give you the next bucket. I have to go and negotiate with the operating system and say, hey, now I need enough memory to hold 11 things. So the operating system might say, okay, well, that plot of land is over here, all right? Where Arraylist and in 300, when we start implementing our own linked lists, they're going to say, hey, look, you know, I'm initially going to give you this place in memory to hold Arraylist, probably set aside some space. But then once you go farther than that, if you add an 11th element, it's going to automatically jump to a new place in memory that allows you to hold some more stuff. Okay, and Arraylist do that management for you. But the benefit we get related to Arraylists using them is we don't have to know the number of elements we're going to store before we start using it. All right, that makes sense? And we don't necessarily care how inefficient memory-wise it is under the hood. All right. And then since then, we've been talking about, you know, searching and sorting and things like that. And, you know, when I say array list, we can really replace that word with searching, sorting, collections. An array list is a collection. An array is a collection. A linked list is a collection. Last semester, you worked with collections in Python called lists. All of these things are collection types, and we might want to sort them, find things in them, that kind of stuff. All right, so there isn't something special about sorting an array list versus sorting an array. It's really about the nature of the tool the nature of the collection. An array, when we create that collection type, we have to specify how much stuff is going to get held. Whereas an array list, we don't. And we can just start filling it with stuff. And where we noticed that, where we experienced that through one of our code examples in classes, when we first were digesting that JSON string from the internet, what did we do? I think we kind of created a counter, right, to find out how many minions there were. I don't remember what it was, but I don't know, I say 9,000 minions or something, whatever the number was. And then we went and we hard-coded an array to hold just the right number of minions, right? Hoping that that data source didn't give us more minions than that, where we started walking off the end of it or something. But, you know, we were certainly constrained by saying, okay, I had to know how many minions we were going to find in that JSON before I could store them somewhere, because I needed to build my container for holding all those minions when we were using an array. Switching to an array list, we didn't have to know. We just said, hey, here's an empty array list. It's capable of holding Hearthstone cards. What do? Well, every single time I find another Hearthstone card, I build an instance of Hearthstone card and I toss it into my array list. And my array list will manage memory under the hood in whatever way it does. We don't care. Okay? So those differences between arrays and array lists in terms of when one is the right tool for the job versus the other are things that will probably show up on the exam. If you know how many elements you're working with, an array it's fast, it's simple, has everything going for it. An array. But if you don't know how many elements you need to store, arrays are going to be burdensome, because you need to, when you create an array, you have to specify how much stuff this thing's built to hold. So in that case, something like an array list is going to be more appropriate if you just have no idea how much stuff you're going to be holding. All right, and like I said before, when we're dealing with the searches and the sorts and stuff like that, I'm not going to ask you questions about the algorithms. Like, you don't need to go in here and memorize this slide for the 5 steps for the selection sort algorithm. All right, what I'm going to be trying to drag out of you on the test from the programming perspective is I'll give you a little puzzle and say, write a function that takes X as a parameter and does something with it, showing that you can follow the guidelines of some kind of algorithm like this. All right, questions about any of that? And like I said, what I'm going to do is I'm not going to give you a homework assignment over the weekend, but I'm going to expect that you go and study this stuff and come with potential questions on Monday so that I can show you examples of things that you want a clarification on, so that when Wednesday's class comes along, when you actually take the exam, you're all prepared for it. Okay, I am going to start some new material now, and I'll also continue with that new material on Monday after we've answered any questions. But the time is yours. If you want to spend the whole time on Monday reviewing stuff, we can do that, but you'll have to come with questions. All right, so before I go on to new stuff now, are there any questions you have for me in preparation for preparing for the exam? Go ahead. I did. The grades are posted. Are they not posted? If you would, just send me a quick message on Slack. I'll check it right after class. I think everything should be graded up to this point, but there's a sometimes I forget to hit the release thing because I grade them in shifts. I don't always do them all a single sitting, so I have to release at the end. Go ahead. Okay, something's not right. So, so I'll look. If you send me a message, I'll look into all of it. It sounds like something's going on with. Well, it's probably me. I probably forgot to hit the release button, but I'll fix that right after class. Okay, so any other questions about the exam? Okay, so let's start going over to the Android side of things. So I'm gonna write it like this. All right, so we're gonna say Android development. All right. So again, I kind of want us to stay fairly nimble and not get too comfortable in a single environment. You had to get Eclipse up and running, and people are like, oh well, I was having problems with Eclipse. Well, now we're going to switch environments again. Good news is Android. We're going to be using a tool called Android Studio. It actually was based on Eclipse, so it's going to already feel fairly similar. Familiar to you. In fact, in the early days of Android development, you actually used Eclipse with a plugin for Android. Now Google has its own tool for this. Now, if you wanted to go ahead and get the thing downloaded or start the download, it is developer.google.com. And then under products, click Android. So it's actually developer.android.com will take you to the right place. So I'll put that link in the slides here. All right. And the tool we're going to use here, this is where our documentation is as well. So we'll be referencing this a bunch, but you're going to go to Android Studio. And you're going to want to download Android Studio here. The current version is 4.1.2 for the Mac. I'll go ahead and I don't know what version I'm currently running, so I'll just go through the process of doing this. So download Android Studio. I'm on a Mac, so it's going to download this for the Mac. All right, so now while that's kicking or cooking, let's say, we'll check on it in a minute. It's going pretty quickly, it looks like. I'm going to start introducing some concepts that are going to be important to us when it comes to Android. All right, so first of all, our development language is still Java. So we're not introducing a new language at this point. What we're doing is we're changing kind of the sandbox we're playing in with that language. When we were working in Eclipse, we were mostly developing kind of console applications out at a terminal. Not that Eclipse won't let you write graphical user interfaces using a library from Java called Swing, but I didn't introduce it because I knew we were coming and doing the kind of a very similar type of thing with Android. So we looked at kind of the basics of Java first. Now we're going to take that language, that, you know, the Java language that we now have a cursory understanding of, and we're going to say, hey, I want to start writing Android applications versus the kind of applications we've been writing up to this point. So maybe a question to ask: what is the difference between the programs we have written so far in 200/250 and an Android app? And, you know, we can say Android/iOS app, because the stuff we're going to learn here via, you know, related to Android is going to translate to iOS as well. The reason I choose Android is because Android Studio is available on Mac, Windows, Linux, whereas Xcode, which is the tool for writing iPhone apps, is only on the Mac. And not everybody in here has a Mac. A lot of the things are going to be very similar. So if you learn how to develop mobile applications for Android, switching over to doing that for iOS isn't a giant leap. All right, but just based on your experience as a user, when you download an app off the App Store on your smartphone, what's different about those applications versus the things we've written so far in 200 and 250? There should be one obvious one, right? User interface. You know, you expect pictures and buttons and stuff like that, right? Where up to this point in 200 and 250, we've basically seen a text-based experience, you know, where if we want to ask the user some information, we prompt them with something and then read in a string or a number or something like that from them, and then do something with it and ultimately spit it out to the screen. We've been practicing the logic side of things and the algorithms behind the scenes, but we haven't necessarily really been considering that interaction between the end user, giving them an interface that actually makes the, you know, your code come to life, so to speak, and be kind of usable. So one of the things we demand is, we can say an Android app demands a user interface that allows the user to speak to our code through a familiar interface. So now, is it true that whenever you download an app from the App Store in your smartphones, that you don't have to be trained necessarily on that specific app? You can pretty much, like, when you have like a create account button, you pretty much know where you're gonna have to go through, right? You click the button, you put in a couple of pieces of information, maybe you enter your password twice, that kind of stuff. So we already have this like common understanding just from using technology of the things that graphical user interface applications have. They have buttons, they have drop downs, they have swipey things, right? All sorts of stuff like that. All right, so there's an expectation for that, and the Android ecosystem provides us those tools for creating those things. So now we're going to introduce a new dimension to our computer programs, and that dimension is now we're not only thinking about doing something algorithmically, but we're also thinking about, how do I get information from the user and how do I present information to the user? We do this at a more formal level when you take the CSC250 class, the user experience class, where they kind of talk about why user interfaces are built a certain way. We're not going to focus on that in here. We're going to build pretty, you know, weak interfaces, but they will be interfaces with text boxes and buttons, and you click a button and something happens, and and that kind of stuff. So, you know, we'll kind of take our applications to the next level when it comes to that stuff. But we're still going to be doing all of this in the context of Java. So Java is going to still be the programming tool that we're going to use for our logic, but now we're given some new Legos to work with, because now that we're operating inside of the Android ecosystem, the Android ecosystem provides us with a whole bunch of little widgets for making Android applications. You know, when you have a list of things that you can scroll through, Android gives us that list of things, then you use Java to attach to it. You hook up a Arraylist, for example, to our array adapter, and that guy makes the stuff that's inside your array list show up in that list that you can scroll through on your Android app. Okay, so now we're marrying our logic to these widgets that Android's providing for us. All right, so let me go back in here. I'll go ahead and open up this Android Studio thing. I already have it on this computer, but I might have a dated version, so I'll just make sure I have the same version all of you have. So I'll go ahead and drag that in there. It's asking me if I want to overwrite it. I'll go ahead and say replace. Okay. So now I should be able to open up Android Studio on my computer. All right. Hit open. All right, I'm going to go ahead and just close that project right there. A lot of you are going to see something like this. So I'm just going to kind of give us a little quick demo. So this is version 4.1.2. I'm going to create a new project. And I typically, when I create projects, so notice here, like I was saying, that the Android ecosystem gives us a whole bunch of starting points for writing Android applications. So we can kind of look through this and see, oh, look, I mean, here's, you know, you have a, here's an app that has like a tabs on the bottom for you to flip between screens. That might be your starting point. Here's a full screen application. Here's a Google AdMob ads activity. So if you want to include ads inside of your app, you can write it from scratch, but this guy gives you kind of like a starting point where, hey, you're going to write an app that's going to talk to Google's ad ecosystem. Let us go ahead and give you that starting point so you can easily bring that into your app. Same thing if you're going to do something with Google Maps, or you're going to have stuff with logging in or scrolling or any of these things. There's starting points for all that stuff. We're not going to use any of those starting points. We're always going to start off with an empty activity. Okay, not a basic, not no activity. We're going to start off with an empty activity. Now notice here that the same tool here that can be used to write phone and tablet apps, as well as Wear OS stuff. So like like watches, things like that, Android TV, stuff for Android Auto, runs in the car. So you're going to use this exact same tool for writing all those applications. Okay, but we're going to choose empty activity here. I'll go ahead and hit next. I'll just leave all the default stuff here. Now, the default language here for me is Java. It might have been something different for you because there is another language in here called Kotlin. All right. Kotlin is kind of like maybe their competitor with Apple's Swift language, but it hasn't gotten popular yet. We're going to be working in Java. Okay. So make sure the language says Java. Now we get this thing called minimum SDK, and this is where things get a little interesting when it comes to Android. Back in the early days of iOS versus Android, one of the complaints that the Apple people use to say this is why Android sucks is, you know, they would say, well, the Android ecosystem is fragmented, which means that, you know, there may have been more physical Android devices in the world than there were iPhone devices, iOS devices. But a high percentage of the iOS devices were all running the newest, latest, greatest version of the iOS operating system. So they all had the same capabilities, minus maybe a little bit different speed or camera resolution, things like that. But all the devices were running the same core operating system. Android didn't work that way, and still doesn't work that way. So Android, when you get a phone, it's running whatever version of Android was out at the time, probably for that phone. Maybe not the bleeding edge one, but the one that's stable. And then you're at the mercy of whenever a software update comes out from your phone vendor. And what I mean by that is because Android is an open source operating system, it's similar to Linux, where you can have different distributions of Android. So for instance, I run a Samsung Note 20 Ultra. So when I first got my phone, it had all of the Samsung bloatware stuff on it because they took the Android operating system and said, we're going to make some modifications to it to make it Samsung-y, which now means that it can't run, well, you can make it work, but it doesn't run the native core Android operating system. It runs a modified version of the Android operating system that Samsung has said makes it better. All right, so, you know, Google, built into Google, their version of Siri is called Google Assistant, right? Well, Samsung decided, well, Google Assistant's not good enough, so we're going to introduce a thing called Bixby, which doesn't work very well. But what's interesting is between the three of them, each one of them, so Bixby, Google Assistant, and Siri, each one does some things better than the other ones. None of them do everything very well. It's just kind of an interesting thing that a lot of these things are possible. But Samsung's made changes to it. So even though I'm running Samsung's flagship phone, let's say, when a new version of Android comes out, I probably have to wait 2 months or so before it's available to get on my phone because I have to wait for Samsung to make changes to it. Now, and that's working with one of the flagship companies, right? So if you want to run the latest, greatest version of Android, always, you operate with the Google Pixel. Then you're running the latest version of Android. All right, but this problem has been going on for a long, long time. So you notice this minimum SDK, this is the software development kit. You're saying, which bag of magic tricks do I want to have available for this application I'm about to write? All right, and if you hit this drop down, notice the one it's suggesting here is API 16, which is Android 4.1 called Jelly Bean. This is a very, 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 very old version of Android. Notice that right now, Android Q, API 29 instead of API 17. So this is from a long time ago, Jelly Bean. They're basically saying, if you write for Android or for API 16, your application will run on, it says 99.8% of the devices, the Android devices that are out there. With that in mind, if I switch this so I'm running Q on my Galaxy phone now. If I switch it to this, it says, it'll work on 8% of the devices out there. So you say, well, why would I go and write software that only works, that's targeted for Android Q? Why might I choose to do that even though it'll only work on 8% of the devices? Good. Huh? Well, tell me more. What do you mean by better processing? The devices probably have better speeds, but I can write an API 16 and still take advantage of those better speeds on those faster devices. Go ahead. Okay, you said framework for the coding. What do you mean by that? Yeah, so something changed between API 16 and API 29, right? Some of the things that changed might have been bug fixes and stuff like that, but there's also new kinds of widgets that maybe are supported by Android Q that weren't supported previously. And part of that might have been because the devices now are faster and you can have cooler animations and crap on the screen where that would have bogged down a phone from a decade ago, right? So the idea is that with a newer version of Android, you're getting backwards compatibility for the most part, but you're also running into some situations where it's saying, here's some new stuff that we're allowing you to work with, but this stuff's only going to work on Android Q and newer operating systems. So if you're saying that I'm going to write an API 16 Jelly Bean, you're saying I'm only going to put stuff in my application that takes advantage of the widgets that were available back then. And we can say maybe for most mobile applications, that's fine, right? We're not trying to do anything super fancy. We're just writing an app like things we're doing in here. API 16 is fine. But if you're doing something, you know, very cutting edge or something that really relies on some brand new feature that Android just released or something, the trade-off might be that your software is only going to run on like the current flagship devices, which might be okay because that might be your target audience. Your idea might be, even though it's 8.2% of all Android devices out there, you might say, well, you know what? The people that are willing to pay me money for my app are probably those 8.2% of the people. So I can target them. All right. So we'll pick up here next time, but we are going to leave it at API 16, and we'll go ahead and create that app. So I'll just hit finish here. Well, that's like the next version. Oh, you want a Pixel? Okay. All right, so we have this started. We'll look at how to get this running next time. This is our basic Hello World application in Android is what we're going to run, and we're going to have to look at using the and creating an Android virtual device next time, so we can run our Android applications on our computer rather than having to plug in a phone. If you do have an Android phone, running it on your phone is actually quite easy. But many of you might not have Android phones. You won't need one. You can run it through the emulator on your computer. All right, questions, comments, concerns, bribes. Okay, and I'll go back to my office right now, and I assume I'll see a message, but I'll figure out what's going on with Blackboard. I'm sure it's user error. I'm sure I did something. So you should see presumably a grade dump of a bunch of stuff here in the next 20 minutes. I apologize for that. Let me know, because I typically try to grade assignments like the day they were due or the next day. So if you see breaks where you're not getting feedback from me, let me know, because that means I assumed I hit a button and I didn't. All right, I will see everybody on Monday, hopefully with questions to cover on the in preparation for Wednesday's exam. Otherwise, we'll keep trucking with Android.